Now let's talk about the acidity of phenol. Phenol, when placed in aqueous solution, can donate its positive ion, its proton basically, forming the phenoxide ion plus the H positive ion. So since the phenol has donated its proton or has formed H positive ions in aqueous solution, phenol is acidic. Now, and similarly, ethanol CH3 CH2OH in aqueous solution also dissociates to form an ethoxide ion plus H positive ion. Phenol has also donated its proton, forming an ethoxide ion. Now, if we look at both of these, both of them are weak acids. Both the phenol and ethanol are weak acids, but which one is stronger? That's we are gonna compare. Phenol is a stronger acid as compared to ethanol. Phenol is a stronger acid, stronger. Remember, it's not a strong acid, but rather a stronger acid compared to ethanol. Both of them are weak acids, but we are just comparing. That's why I'm using the word stronger. And ethanol is a weaker acid. Okay, now why? The why is important. And it has been asked for like 3 marks. So the comparison, and it's basically a very frequent question in the past papers. I've seen it many times coming in many different years. So this is an important part that I'm going to discuss right now. Phenol over here has a conjugate base, the phenoxide ion. This is the phenoxide ion, and this is the phenol. Basically, if we look at the phenoxide ion, this negative charge, the oxygen has its lone pairs. The lone pair gets delocalized over the benzene ring. It gets distributed over the benzene ring. So does the negative charge gets distributed over the benzene ring. So the negative charge gets distributed over the benzene ring, distributed over the benzene ring. Since the charge gets distributed over the benzene ring, this charge distribution increases the stability of this base, the conjugate base of the acid. This is our acid, and this species over here, the phenoxide ion, is the conjugate base of the acid. Now, if we increase the stability of the base, what happens is that this negative charge, the magnitude of this negative charge, it actually decreases. So when the magnitude of this negative charge decreases, it will less likely get attracted to this positively charged H positive ion and is less likely to go back in this equilibrium. This is an equilibrium reaction, a reversible reaction. So basically, if this negative charge gets the magnitude of the negative charge decreases, this conjugate base is less likely to accept the proton. And if it's less likely to accept the proton, this phenol will remain in the dissociated form. And since it remains in the dissociated form, it remains dissociated. So any species which is uh, which is dissociated to a greater extent is a stronger acid. So acids remain dissociated for a strong greater time. So increase in stability of the base, okay, of the conjugate base. By the conjugate base, I mean the phenoxide ion, the phenoxide ion. So basically, the base is stabilized due to the electron delocalization over the benzene ring, stability of the benzene. Increase in stability of the conjugate base would mean that the base have become a weaker base. more stable and weaker base. Weaker base because it is less likely to accept the proton and form the undissociated phenol again. So the phenol remains dissociated and hence it is stronger. Okay, why is ethanol a weaker acid? Basically, ethanol is a weaker acid because, again, we are going to explain it in terms of the stability of the conjugate base. In ethanol, there is an alkyl group. The ethyl group over here is attached to the oxygen, the negatively charged oxygen atom. This alkyl group, as we know, all the alkyl groups have a property known as the positive inductive effect. Alkyl groups are electron donating groups. Basically, electron donating, basically they release their electron density due to an effect known as the positive inductive effect. Now this positive inductive effect, this is the keyword that you need to use in your answers. So due to the positive inductive effect, this alkyl group over here, it pushes its electron density towards this negative charge. What happens next is that the magnitude of this negative charge, it increases. As the magnitude of the negative charge increases, this base, the conjugate base, is destabilized. The conjugate base, the ethoxide ion, is destabilized due to the positive inductive effect of the alkyl groups. And as the negative charge increases, it is more likely to accept the proton because the opposite charges would attract each other. This negatively charged ethoxide ion would accept the positively charged H positive ion and will again form the undissociated ethanol molecule. So the percentage dissociation and ethanol in aqueous ethanol is lesser. Percentage dissociation is lesser due to the uh, destabilized or destabilized conjugate base. So this was the explanation of why phenol is a stronger acid compared to ethanol. Now, out of all these points, what are you gonna write in your exams? Basically, the question comes somewhat like this. They ask you which acid, uh, describe and explain the relative acidity of phenol and ethanol. Okay, this is the question, and for most of the times it's for 3 marks, 3 marks only. You've got a lot more points than for 3 marks. So what are you gonna choose in these? First mark is for saying, for this statement, that phenol is a stronger acid compared to ethanol. First mark is for the statement phenol is a stronger acid compared to ethanol. Okay, the remaining 2 marks are for the explanation. Okay, you'll get a second mark if you say that the phenoxide ion, go directly to the conjugate base. The phenoxide ion is more stable than the ethoxide ion. Okay, both are the conjugate bases. We've compared the conjugate bases. The phenoxide ion is more stable than the ethoxide ion. You'll get the second mark. And why is it more stable? So the third mark, you'll get the third mark when you say that the negative charge of the phenoxide ion is delocalized or distributed relocalized or distributed over benzene ring, due to which it is less likely to accept the protons, and due to which it is less likely to accept protons. Okay, you've achieved all the three marks. But now, what are the additional points that you may include in your answer? Basically, the alternative valid points of the marking scheme. Uh, the negative charge of phenol is delocalized over the benzene ring. This has been covered. And you may write about the positive inductive effect in the ethoxide ion. At Due to the positive inductive effect, the ethoxide ion is destabilized. This is your additional valid point that you may include in your answer. I would suggest that you must include it in your answer to be on the safe side. Now, uh, phenol is more stable than ethanol. Phenoxide ion is more stable, and the negative charge of the phenoxide ion is delocalized, due to which it is less likely to accept the protons. And due to the positive inductive effect, the ethoxide ion is destabilized because this will increase the negative charge over the oxygen atom, and it will accept the proton more readily. So this is basically the comparison of acidities of phenol with ethanol. So guys, this is a very important question and it has been frequently asked. Okay, so thank you so much. Between the next video on reactions of phenol.